Welcome to Sundar's lecture. This is lecture number 84, and in this lecture we are going to see some problems related to coupled coils, right? So what are the topics we have seen in the previous class? See, we have started with the energy stored in mutually coupled coils, and then we have taken this diagram and we try to find what is the power expression, and then we have derived the expression for energy stored in the coupled coils, right? What is the final answer we got? W is equal to half L1 I1 square plus of L2 I2 square plus M into I1 I2, right? This is the final energy stored in the coupled coil at steady state. Why we are saying it is steady state? Because the current will rise up to some time, and then it will tend to stable, right? So after getting the steady state condition, this currents can be determined, right? So that is why I have used this formula. And then we have seen what is coefficient of coupling, right? What is coefficient of coupling? Whatever the flux produced in the first coil and how much of flux that is going to link in the second coil. Maybe there will be some leakage fluxes, right? Those leakage fluxes has to be taken into account if the coils have some problems in uh, with the cores. Maybe if the windings and cores are not exactly wounded, then there will be some leakage fluxes, so that the all fluxes from the coil 1 cannot be linked with the coil 2, and we need to know how much of fluxes has been linked with the coil 2 or coil from coil 2 to coil 1. So that is what we have found, and the value of K, it is mutual inductance divided by root over self inductance of coil 1 multiplication of self inductance of coil 2, right? This is what we have seen in the previous class, and now we will take some problems to get a good clarity, right? So I will read it out. Two coils are connected in series with the self inductance of 2 Henry and 4 Henry. So what they have given, let us write it down. Two coils are connected in series, right? So two coils are connected in series. So the diagram will be like this, right? The diagram will be two coils, right, connected in series, right? So what they have given you, L1 and L2, right? So the value of L1, it is 2 Henry, right? 2 Henry, and then it is 4 Henry, right? It is 4 Henry, and respectively the mutual inductance of both coils are 0.05, right? So the mutual inductance, it is 0.5 Henry. 0.5 Henry. Find the equal inductance if the coils are aiding, if the coils are opposing. Try to understand. If both coils are aiding and both coils are opposing. So first, if aiding, then it will be the diagram like this, right? This is aiding. This is for aiding, and we need to find. No, okay, fine. We know the formulas, right? So L equivalent of the value will be is equal to, if it is aiding, so that will be L1 plus L2 plus 2M, right? This is the formula for aiding. We have seen, right? We have seen. See this one, parallel series aidings and all those kind of things we have already seen. See where it is? It is parallel aiding. See, we have written the formulas aiding for aidings, right? So you try to understand. And for opposing it will be minus 2m, right? So we need to get the values exactly. That is why I have shown you. And now if this is the formula. Try to substitute in this formula now. It is 2 plus 4 and then plus 2 into 0.5, right? So if it is so, then the final L equivalent value will be is equal to, if I am doing this one, I will get 7 Henry. 7 Henry. So this is the final answer. So let us we go fastly, right? So and then if the coils are connected in uh, a the first one, this is first one, right? This is for aiding. This is for aiding. And for the second condition, what they have given, if the coils are opposing in series, right? Try to understand. Both are in series, right? So how will the diagram will be now? This is for opposing. So if it is opposing, then it will be like this, it will be like this. So this is 2 Henry and this is 4 Henry and this value will be 0.5 Henry, right? So this is the diagram. And what is the formula? And L equivalent will be is equal to L1 plus L2 minus 2M. That is the formula. And what will you get here? 2 plus 4 minus 2 into 0.5, right? This is the formula. And finally, if you simplify this value, I am getting 5 Henry, 5. L equivalent will be 5 Henry. See, try to understand one thing. If it is aiding, if the coils are aiding, series aiding, the value of equivalent inductance value becomes higher compared to the opposing. That is the point you have to understand. Anyhow, I am not taking too much of time to explain these kind of things, right? Then what is the next one? And we need to find what is the coefficient of coupling. So I will take it to the next page. I will just write it down the given data. L1 is equal to 2 Henry and L2 is equal to 4 Henry and M is equal to 0.5 Henry. And we need to find what is the value of coefficient of coupling. Coefficient of coupling, that is the third case, right? Third case, K value. What is the formula for K? M divided by square root of L1 and L2, right? This is the formula. And if I substitute in this formula, it is 0.5 divided by square root of 2 multiplication of 4. And if I simplify this, so if I simplify this, the value of K comes out to be 0.176. So this is the coefficient of coupling for these two coupled coils, right? Next one, what is the next question? Fourth question, this one, parallel leading, right? So I will write it down. What is parallel leading? Fourth question, it is parallel aiding. So if it is parallel aiding, maybe I will draw the diagram. So this will be like this, right? Right? This will be like this, and this will be here, this will be here. And this is 2 Henry, this is 4 Henry, and what is the mutual coupling? Mutual coupling, it is 0.5 Henry. Try to understand. The diagram will be like this, right? So what is the formula we have seen for L equivalent if it is parallel leading? It is so what is the formula? It is L1 L2 minus m square divided by L1 plus L2 minus 2m. This is the formula, right? We have seen, we have derived in the previous class, right? So if I substitute, so L equivalent will be 2 into 4, 2 into 4 minus of 0.5 square and divided by this L1 L2 minus 2m, right? This is series. Here you would have got this value. What is this one? This is 5 Henry, right? This is 5. We have already found. And if I simplify this, I will get L equivalent to be, I am getting it to be 1.55 Henry. 1.55 Henry, right? This is the final expression. And what is the next question? Next question. It is a parallel opposing, right? Parallel opposing. Fourth one, parallel opposing. So parallel opposing, the same diagram will be same. What it will be? It will looks like two coils connected in parallel like this, and if it is opposing, then this dot will be here, this dot will be here. 2 Henry, 4 Henry. See, I am just drawing these diagrams to get good clarity. Try to understand. I don't need to draw this one because I know the formulas. But anyhow, you don't write the formulas directly. Don't mug up the formulas. Try to understand the concepts and then you try to do problems. Then only will get a good idea. Not don't mug up anything. So what is the formula I have written? We have derived. This is L equivalent will be is equal to L1 L2 minus m square, and this is divided by L1 plus L2 plus 2m plus 2m. This is the formula for parallel opposing. Then if I substitute, L equivalent will be is equal to 2 multiplication of 4, the same value, 2 multiplication of 4 minus 0.5 square divided by, see this one is series 18, 7 Henry. You can easily substitute. This is 7 Henry. So if I substitute this, I will get the value of L equivalent will be is equal to, I am getting it to be the value, it is 1.107. It is 1.107 Henry. 1.107 Henry. Right, this is the final answer. See, try to understand one thing. See here, what is the equivalent inductance if coils are parallel aiding? It is 1.55. What is the equivalent inductance if parallel opposing? The coils are opposing connected in parallel. It is 1.107. Here also, aiding gets more inductance and the opposing gets less inductance. So try to understand. Compare these two, you will get a good idea. And what is the next one? We need to find the voltage equation in each cases. If I is equal to 20 T, see I will anyhow I will write down here itself. See what is the voltage equation? What will be the voltage? V is equal to L equivalent of D into I divided by dt. This is the expression, right? If you simplify this expression, this will be 7. 7, that is the L equivalent value, d by dt of, what is the formula we got it? What is the equation you got for I? It is 20 sine t. It is 20 sine t. And if you substitute this V of t will be is equal to, this will come out, right? It will be 20 means it is 140, right? It is 140 and cos of t, this is the expression, and this is for this, maybe I will write it out also. This is the voltage expression, voltage, right? This is the voltage expression. Same thing, see, if you once differentiate this one, you will get, I will write it down anyhow. See, di by dt, this value will be constant, right? The value will be 20 cos of t, and you need to multiply. That's all. See, what is the voltage expression here? This will be is equal to L equivalent di by dt. It is the value we have already found, right? What is this one now? So I will write it down here. V of t will be is equal to, what is L equivalent? It is 5 into 20 cos of t. So finally what you will get? You will get 100 cos of t. That's all. Right? This is the voltage equation. And for this one, maybe I will write here. V of t will be same formula, right? It is 1.55 into what is the value? 20 cos of t, and V of t I am getting it to be, so it is 31 cos of t. Okay, fine. Then I am writing this one here. This is for parallel aiding, and this value V of t will be is equal to 1.107 into 20 cos of t. And if I simplify this, so I am getting 22.14 cos of t. This is for parallel opposing. See, we have found, right? We have found all the values, right? This is the given question and we have found. And now we will take another problem too. See this one, two coils are connected in series, have an equivalent inductance of 10 Henry, when connections are when connections of one coil is reversed, the effective inductance is 6 Henry. If the coefficient of coupling is 0.6 Henry, calculate self-inductance and mutual inductance of each coil. Try to understand one thing. If the two coils are connected in series have an equivalent inductance of 10 Henry. So, see, one thing you need to understand. See, they have not given like it is series aiding or series opposing. Right? They should have given you, right? You know the formulas, right? What is the L equivalent formula? L equivalent will be is equal to L1 plus L2 plus 2M plus 2M, and you know the another formula. L equivalent is equal to L1 plus L2 minus 2M. This is for series aiding and this is for series opposing, right? But the thing is, they have not given you the series aiding or series opposing. That is why we have solved this problem. Try to understand. Here, you see, always if it is aiding, the value of inductance, equivalent inductance will be higher than the opposing, right? So this value, this 10 Henry is aiding, series aiding, and the 6 Henry is series opposing. You have to understand. That is what they have given you, equivalent inductance. So if I write the equation, this is L1 plus L2 plus 2M, which is equal to, what is the value they have given you? It is 10 Henry. This is expression number 1 now. And L1 plus L2 minus 2M, which is equal to 6 Henry. That is what they have given you. This is the expression number 2. And you see here, if I add these two expressions, if I add these two expressions, what I will get? This value can be cancelled out, right? Straight away. So I will get, no, sorry, 1 minute. If I minus these two expressions, this will be like this, and this will be plus, and this will be also minus. So you see here, this is plus, this is minus. So this can be cancelled out, and this can be cancelled out, and finally what I will get, it is 4m, which is equal to, if I minus these two, I will get again 4. Am I right or wrong? So this is the expression now. So if I simplify this straight away I will get the mutual inductance. What is the mutual inductance? It is 1 Henry. It is 1 Henry. Simply. See one thing you need to understand. Now, what is the question they have asked? Asked you to find the coefficient of coupling value they have given. Calculate the self-inductance and mutual inductance. We have got the self-inductance value, right? Sorry, mutual inductance value. And we need to find what is the self-inductance. So, how will you find the self-inductance? You need to get what is the L1 and then the value of L2, right? So what is the thing they have given you here? They have given you what is the value of K. See, you substitute this 1 Henry in one equation, maybe substitute M is equal to 1 Henry in expression number 1 maybe. So what you will get here, it is L1 plus L2 plus 2, which is equal to 10, and if I further simplify this, L1 L2 is equal to 8, right? So this is expression number maybe I will put it a different number, 3, expression number 3. Even if you substitute M here, you will get the same answer, same expression will be there. And you know what is the value of K they have given you, that is 0.6 Henry, coefficient of coupling they have given, right? Right. What is the coefficient of coupling formula? K is equal to M divided by square root of L1 into L2, right? So you know, try to understand one thing here. One thing, what is this one? See, I know the value of K and I know the value of M. K is given, M I have already found. So what you do, you just square both sides. What you will get, this is K square, which is equal to M square divided by L1 into L2, right? So if I get this value to the other side, what I will get, L1 into L2, which is equal to M square divided by what? K square, and if I further simplify this, this is 1 divided by 0.6 square, right? So if I do so, so I will get L1, L2 is equal to 2.77. Try to understand from expression number 3, what I can write. So L1, maybe I will write L1 is equal to this value. You just write it down as 8 minus L2. You can bring this one. So now you substitute this one here. Maybe, yeah, instead of L1, I can substitute 8 minus L2. 8 minus L2 into L2 is equal to 2.77, right? So if I further simplify this, I will write the final expression. You will get a quadratic equation, right? So I am getting L2 square. I am just writing it a final. I am just writing the final expression. L2 square minus 8L2 and then plus 2.77, and that should be is equal to 0. So expression number 4, right? This is nothing but a quadratic equation, and you can easily simplify this. Use minus b plus or minus square root of b square minus 4ac whole divided by 2a. This is a coefficient is 1, b coefficient is minus 8, and c is 2.77. Try to understand. I am not going to do those kind of things. You yourself find these values. So if I get so, I will write the final expression. What is L1 and L2 straight away, right? Straight away. L1 is equal to, I am getting this value L1, it is 7.63, and then see one thing, see we are finding L2, right? L2, for L2 you will get two values because it is quadratic equation. Since it is quadratic equation, you will get two expressions. What is this one? L2 is equal to 7.63 Henry, or you will get 0.36 Henry, both values, right? So both are positive, so it is both values can be taken into account. So if L2 I am taking it to be 7.63 Henry, then what will be L1? L1 formula I have just written here. L1 is equal to 8 minus L2, right? So 8 minus L2. So what I will get? 7 minus 6, 8, 8 minus 7.63, and L1 will, you will get it as 0.37 Henry, right? Then if L2, I am taking this value now, 0.36 Henry. Then also, what is L1? L1 will be is equal to 8 minus L2. So it will be 8 minus 0.36, and then L1 will be is equal to the value. If I simplify this, I will get 7.64 Henry. So finally, you see here, if L1 is equal to 7.64 Henry, then L2 will be is equal to 0.36 Henry. This is one condition. And if L1 is equal to 0.37 Henry, then L2 will be is equal to 7.36 Henry. 7.36 Henry, right? So both values, you will get two answers, right? So this is the final expression. We have got all the values, right? L1, L2 and M. Right, we will go to the next problem now. Third one, two identical coils are connected in series as equivalent inductance of 0.08 and 0.0384 Henry in series aiding and opposing respectively. So see, they have given you directly, right? So what is the expression? L1 plus L2 plus 2M series aiding, the value it is 0.08 Henry. This is expression number 1. And opposing, it is L1 plus L2 minus 2M which is equal to 0.0384, right? This is expression number 2. And you see, you need to find what is the value of L1 comma L2, and you need to find what is the value of mutual inductance and also what is the value of K. This all things you need to find, right? So simply whatever we have done in the previous problem too, you have to follow the same procedure here. Just minus this one, this becomes plus, and this will become minus. So straight away this value becomes 0, this value becomes 0, and this will become now 4m, which is equal to, if I further simplify this, what I am getting, so here I am getting it to be 0.0416, right? So if I find what is m from here, m will be is equal to 0.0104 Henry. 104 Henry. This is the value of mutual inductance. Straight away I will get this value straight away, right? So now what you do, you just substitute this m in expression number 1 or 2, you will get the value straight away. So see here, this m, substitute in expression number 1. Substitute in expression number 1. What you will get here? So L1 plus L2 plus 2 into 0.0104, which is equal to 0.08. Try to understand what is the condition they have given you. It is two identical coils. Two identical coils means then the value of L1 will be is equal to L2 will be is equal to L. Try to understand, right? So if I substitute, then I can put this L1 as L2. So L2 plus L2 plus this value. If I simplify this, what I will get, I am getting it to be 0.0208. Right? This is the value, which is equal to the value. What is this one? This value. This is 0.08, right? So further simplification, further it is 2L2, which is equal to 0.08 minus 0.0208. So if I further simplify this, I will get L2 to be 0.0296 Henry, and because this is identical coil, the value of L1 will be same. L1 will be same. And what is the other question they have asked you? K, right? K, that is nothing but it is m divided by square root of L1 into L2, and you see both values are same here. We know m, right? So what is the value of m here? It is 0.0104 divided by square root of 0.0296 square. So finally I will write here, the value of coefficient of coupling will be is equal to 0.3514. This is the final answer. See, we have got all the values, right? M, L1 and L2 and K. This is the final expression. See, we will wind up today. What are all the topics we have seen in this particular class? See, we have taken problems, right? See, this is the first problem, and we have taken all the conditions. What is the series aiding and the series opposing, parallel aiding, parallel opposing, and what is the coefficient of coupling, right? We have taken a single problem to get all the values, and then also we have found what is the voltage expression in each cases. And in the second problem, it is also very easy, not a complicated thing. They have given you equivalent inductance values, right? And then we try to find what is the value of mutual inductance, self-inductances. And also they have given you with the two identical coil conditions, right? It is very simple compared to this problem. We have found what is in quadratic equation, we are getting two different inductances value. In this problem, it is two identical coils. So we have found what is the value of M, L1, L2 and then K, right? We will see in the next class. Thank you.